Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at B1 on our 2016 open paper. If the cubic equation x cubed minus 10x squared plus px minus 30 equals 0 has three positive integer roots, determine the value of p. Okay. So p is one of the coefficients in our cubic, and in general, what do cubics look like? Well, if we've got roots, actually, let me tell you exactly what cubics in general look like so you don't think I'm making a mistake. It's usually some constant times x minus the one root, x minus the second root, and x minus the third root. And these roots can be duplicated and things like that. Now, when we multiply all this out, we get a x cubed minus a times p plus q plus r x squared plus a times pq plus qr plus rp x minus a pqr. All right. Now, so this is what a general cubic looks like. We're not making any assumptions. We even have our leading coefficient here, although if you check the question, you'll notice that that's going to be a 1. But these pq's and r's, they could be real numbers, complex numbers, or anything. Now, we are told in the question that we've got integer roots and that they are, I think they said distinct. No, they didn't say distinct. They just said three positive integer roots. Okay, so we know p, q, and r, and we've got integers. Now, if we compare this to what we've got x cubed minus 10x squared plus px, I think it was minus 30. Yes. Okay. So what does this immediately tell me? A is equal to 1, which is why I started the question not even bothering to write it, but since I said general cubic, I decided to add it in. So that really means that, hey, we can ignore A. And so now I know I've got three integers whose product is 30 and whose sum is 10. Now, this is two equations with three unknowns. We shouldn't be able to solve this uniquely, but because we're dealing with integers, I think this probably won't be that bad. My first guess is 2 times 3 times 5, just because 30 is 2 times 3 times 5, and it's something you just sort of pick up after a while, that when you talk about integers and 30 is the smallest number that is a product of three distinct integers, which is why I think my mind even filled in the blank and thought that they should be distinct integers, even though they didn't say that. But if we check, 2 plus 3 plus 5 does in fact equal 10. Now, you could go experimenting and playing around with this and trying other combinations for 30. The way you would go about doing this is remembering 30 is 2 times 3 times 5. This is its prime factorization. And that, to me, really suggests you should do the 2 times 3 times 5, but you could have grouped it other ways. 6 and 5 and 1. Did they say positive integers? I know I keep bouncing back and forth. Yeah, positive integers, so we wouldn't try any negative numbers. But we could have also tried 30, 1, and 1. And you just keep experimenting. There's only so many ways to factor 30 into a product of three numbers. You would just check for which one's 10. If you don't see the 2 times 3 times 5 and make that your first guess, then this question might take you a bit more. A bit of time. But 2 times 3 times 5 works, so what is P? 2 times 3 plus 3 times 5 plus 5 times 2, 6 plus 15 plus 10, and that's going to be 31. Okay? So P is 31, that's our final answer. Now, we've got a full quadratic here. Or not quadratic, cubic. You could even try to double check this by saying, well, is 2 really a root of this? And so 8 minus 40 plus 62 minus 30. So that would be these two combined to be 70, and so do these two. And you can just keep checking from there on out. You can check 3 and 5 and make sure that they really are roots, that you got the right p-value in the end. You don't have to do that, but you certainly could. But 31 is going to be our final answer, and that's B1. So we're going to move right along to B2 in the next video.